At this time, I'm pleased to introduce our presenter. Aldo oversees business development and operations while leading a management team and engineering staff. With more than 30 years of experience in automation and information technology industries, he's achieved great success in providing turnkey solutions to clients in the technology sector, including the manufacturing, transportation, and municipality industries. Beyond software engineering and automation controls background, he has extensive knowledge in machine learning, predictive analytics, and IoT technologies. At this time, I'm going to go ahead and turn it over to our presenter. Welcome, Aldo.
Good morning, everybody. It's a pleasure to be here today to share our knowledge and experience with the CSIA community. We are a digital transformation company, and we leverage artificial intelligence and IoT for predictive maintenance, process optimization. As it says, our premise is data and time are valuable assets that are underutilized and possess huge economic opportunity. Our industry domain experience coupled with our technology, which we'll talk about today, Sorbo, offers a true end-to-end IoT solution. Just a little bit of history in our journey. We started back in 2004 as a traditional systems integrator offering a la carte services like PLC programming, HMI, drive, SCADA. We also designed and built our own control panels. Later on, we added both OT and IT services. We partnered with a company, Parsec, with their product called Traxxas to offer OEE and MES solutions, as well as became an ignition solution provider, as well as Siemens, Wonderware. And the last 5 years, when really IoT and predictive analytics were just coming into our industry, we adopted a technology platform called Sorbo, which I'll talk about. So a few items I'd like to talk about is what we see and how traditional system integrators will be impacted in the future. And really it's an understanding of these new paradigms and how our services are going to change in the future. Of course, what we'll talk about today is Industry 4.0, the Industrial Internet of Things, and predictive analytics. So you need to be thinking about how to incorporate these into your business, artificial intelligence, machine learning, and it's being driven not so much by the need to do it, but customers are now demanding these skills. Another area is providing remote monitoring services. As a value-added service to your clients, there are integrators now being able to remote monitor their systems that they implement and offer more proactive alerting. So in the event that a system fails, the remote monitoring system integrator or company can then call and say, look, we have a problem. We can offer services to help you solve that problem. Adding data science, being able to understand data and be able to model data to help solve problems in the production area. The shift of software going from the perpetual license model where you're selling an annual maintenance fee to more of a software as a service is really the new paradigm for software. Another area we see evolving is revenue sharing model. There are companies today that are offering solutions based off revenue sharing, combining system integrators with OEMs, with vendors, and building these revenue sharing projects and offerings to clients. Then what I call the urbanization of automation software development. For several years now, the IT world used crowdsourcing for software development, where you basically send out a requirement to the community, online community. They will in turn come back with both commercial and requirements to offer you a solution at a much more affordable and cost-effective approach. In addition to both services, we transitioned the way we approach customers by more of a consultative mindset, offering solutions to customer problems. Applying a model of relating and building relationships and trust with the customer that leads into discovering and understanding their needs, and as well as advocating by offering solutions with supporting the whole life cycle of your system. So this approach, we also looked at moving higher up in the organization, talking not only to the technology owner, but also to the business owner and stakeholders. So through that process, we realized and discovered needs how to impact their business. So customers were demanding more of how to utilize their data better. Just to share you a quick story, 5 years ago, I spoke to a CFO of a large freight rail company and asked a simple question: what keeps him up at night, and what are his highest priorities and concerns in his business? Well, he replied that they needed to reduce unplanned downtime and reduce maintenance costs at the same time. Their largest line item expense on their P&L was maintenance. So this prompted us to understand how we could use data to better predict maintenance problems before they happen, providing better ways to manage and handle unexpected events, and being more proactive rather than reactive. So we look deeper into this predictive analytics and IoT. Boeing claims that 85% of all equipment failures happen on a time random basis, regardless of inspection and service. Emerson's claim is that 63% of all maintenance is unnecessary and causes more problems than it fixes. So looking at the last 100 years of maintenance has really been ineffective in terms of what the value they bring. So the first approach, run to failure, we all know when our car fails, we take it to the service station, they fix it. Not a good approach. Then they adopted more of a calendar schedule where you grease the bearings, tighten the belts every period of time. Then came the metering of usage-based, where you then, after so many hours of operation, you apply some maintenance procedures. Condition monitoring introduced the concept of putting vibration analysis, thermography, ultrasonic. All of these condition monitoring systems provided better ways to handle, but they were all pretty much late stage. Then came the reliability-centered maintenance, where you applied business processes and methodologies to maintenance. So a majority of all maintenance work orders, they were either corrected too late with the wrong symptoms diagnosed, and therefore the wrong remedy was applied. So let's take a look at the evolution of the industry, starting with the Industry 1.0. So the Internet of Things became prevalent in the industry, where it connects real and virtual worlds of production. The fusion of these two worlds via the Internet enabled manufacturers to connect machines, products, and systems involved in the production process. This means that machines and products intercommunicate, and they can independently control each other. So this started off in Industry 1.0 by the introduction of water and steam powered mechanical systems. Then came the electric powered systems in Industry 2.0. And then what we know of today, Industry 3.0, which a lot of us are still adopting, is the use of electronics, computerized systems, numerical control systems, computerized numerical control systems in the manufacturing process. Today, with the Industry 4.0, this integrates cyber-physical production systems, where customers' input determines how and when manufacturers produce their products. So utilizing information and smart automation enable integration of all these embedded production systems and processes, creating this intelligent, object-oriented networking, moving from centralized to more of a decentralized model. And new technologies emerged like cloud computing, edge, quantum computing, shortly coming soon. Big data was introduced, artificial intelligence, machine learning, and deep learning, and augmented reality, and other technologies which are now emerging as well. So the Internet of Things really allowed our company, like us, to basically look beyond just traditional manufacturing, things like smart cities, transportation, utilities. So the market became much larger in the sense, allowed us to provide more opportunities. Data has always been one of our core competencies, mostly on data collection, business intelligence, SCADA, looking at machines, sensors, and controlling systems. Analytics were used to, where we built dashboards, leaving it up to the human to interpret data and making decisions from what is presented to them. Where IoT and analytics now using smart models to make those predictions and analyze and provide insight. So the introduction of big data really allowed more compute and processing ability to data. So the benefits is, of course, going from the traditional relational database in many businesses to run ERP systems, order management, CRM, MES, and factory data collection from structured data. What big data provides is more of structured combined with unstructured data to basically provide what we call the 3 V's, which is process large volumes of data, a variety of different data, and at a higher velocity. For example, if you took a benchmark of a 4.8 terabytes of data in a traditional SQL Server platform, it could take approximately 13 hours compared to using Hadoop or HDFS, where it could process it in 30 minutes. So machine learning versus condition monitoring. Where condition monitoring has been very effective is by applying vibration, thermography, ultrasonic systems, where they can detect before a failure occurs, but as you can see, it happens way down on the degradation curve. So where an accelerometer can detect vibration, there is already wear and tear happening on that equipment. Where machine learning has an advantage is on the process of that equipment. So machine learning can infer mechanical problems by the process, looking at temperatures, pressures, flows. Starting to analyze abnormal conditions in the process might lead to a failure, in most cases much more or much earlier than any type of condition monitoring systems. So today I want to talk to you about the technology that we adopted at our company called Sorbo. It's an IoT digital transformation platform. It's designed with the next level of data analytics, which involves a whole suite of technologies, both IoT, edge processing, artificial intelligence, and machine learning. So what is Sorbo? Sorbo allows you to create models to do anomaly detection and classification, and as well as learning normal behavior. The whole premise of building models is to build what we call a digital twin. There are companies that focus primarily on building digital twin. Digital twin is a way to build a model or replica of your machine or process. Traditional methods, you built simulations based off of rules and based off of knowledge that you gain from the system. In today's digital twin, you build the models through data. So using machine learning and deep learning, now these models become much more sophisticated in how they can replicate a process or machine using a rich set of data. Centralized management was another key area that was missing in the analytics and IoT world. The ability to manage analytics algorithms became a problem, so Sorbo does address this for us. And if you've ever done any type of machine learning or deep learning development, you'll know that one of the key indicators is how well they score and achieving a very high level of confidence. With any prediction, you want to be able to have as close as to 100% probability as possible. So Sorbo incorporates several patented technologies to achieve the best scoring mechanism. Deep domain knowledge experience is really what I think is the key to this industry, where system integrators are key to building this world of IoT and analytics. Because you have to have the domain knowledge, having just a data science and IoT background is great, but really what makes the whole project a success is having the domain knowledge. This, coupled with Sorbo machine learning, provides a whole end-to-end solution for IoT and predictive analytics. Part of the difficulty in building algorithms is having a background in machine learning, which some integrators are obviously have to develop skill set and have to invest in data science experts and machine learning experts. The reason we adopted Sorbo is that it really allowed for engineers like us and subject matter experts to create our own models without having any machine learning or data science experience. The other differentiator with Sorbo is it's really low barrier to entry, both from a commercial aspect, low cost, and from a technology aspect, a very low learning curve. So this platform allows for edge analytics as well as cloud, and we'll talk about that. Most of the analytic companies that you'll see today are primarily cloud focused, but where we see the industry going is being pushed down to the edge, where the processing and decision making is done at the plant, near the process or machine. So Sorbo offers hybrid or cloud only or edge only on premise. Really very flexible. So it provides real-time predictions, failure analysis, and upcoming, where we see the next generation of this technology, is doing the training and the learning online at the facility. The biggest cost to a lot of these analytic predictive platforms is the cost of transferring and processing data. That in some cases is not practical, especially in the transportation field, where moving terabytes and exabytes of data just to build very smart models doesn't make sense. So Sorbo identifies value using big data, and it does it very rapidly and confidently. Predicts maintenance reliability, and it does provide significant countdown warnings to lead time. And this is all based around what we call evidence-based decision making. Just like in a detective tries to solve the crime, he analyzes the data that he gathers and makes some assumptions based on that data. Machine learning and analytics is very much the same. It's providing you this evidence-based decision making to give you better insight and solve problems. With the explosion of open source today, you can download open source from a multitude of areas and use open source to build applications around open source. Open source has really given the ability to look at technology differently. For example, in the world of SQL Server, where you have limitations of how much data you can process and the types of data, these types of systems like Cassandra, Hadoop, and Spark have really gone beyond that limit, giving you unlimited scalability, unlimited processing power. Companies like Facebook, Netflix, they're all using these open source technologies to provide their services to customers with unlimited scalability. Where Facebook has over 1 billion users, there's no SQL Server technology today that exists that can handle that amount of data processing power. With Sorbo, Sorbo implements 3 different open source technologies. We call her hot, cold data. The Cassandra open source is more of a peer-to-peer type clustering technology that is based on NoSQL and provides the real-time historical read and write capability. We call her hot data. For data that's used infrequently, that you only might use whenever you're training a model or running some analysis, Hadoop and HDFS is used for batching and processing batches of data. Spark is where you can utilize distributed computing in-memory processing. It makes it very efficient to build models. Building machine learning models takes a lot of power to process. So therefore, using Spark allows you to use and leverage computers and servers across many different platforms. So Sorbo, as a platform, provides several capabilities. It's Smart Data Collector for edge processing, the Sorbo Historian for the time series data storage. We'll talk the machine learning platform for building and training smart models, what we call agents, and the management platform for managing all the analytics and managing really in terms of object-orientated, managing assets as their types to basically use it to deploy and modify and make changes much faster. The Sorbo Advanced Process Control is using analytics more for process optimization. For example, tuning PID loops or tuning a process to increase the yield of a production line or the quality. So what Sorbo is really, it's like an operating system for, just the analogy is your Windows platform for your laptop. Your Windows platform enables you to run different applications to give you, for example, in Sorbo, data collection, visualization, predictive analytics, and remote management. These applications are all connected and interact with what we call REST APIs in order to share information and provide integration between the applications, as well as connecting to third-party applications. For example, if you wanted to send a work order to a CMMS system using REST API, you can provide and automatically generate work orders. Or if you already have historians, like for example OSI Pi, using a REST API to pull the batch data in order to train smart models, these are all ways that we can interact with third-party systems. So the ability for Sorbo to read and write real-time and historical data, manage and adjust data communications as well is very important, all securely under a development and management platform. And of course, the scalability is the number one thing. So in IoT, you have to have the ability to scale. Looking at a transportation company where you might have thousands of locomotives, hundreds of thousands of systems and equipment, that ability to scale is very important in an IoT platform. The Smart Data Collector is a hardware-based edge processor that sits in a control environment. So a data collector in the bottom there, you'll see the industrial grade, sits in a control panel and DIN rail mounted, and it connects to your Allen Bradley or Siemens PLC via some type of communication protocol. All of the communications are built in. Therefore, you don't need to add another device or another server in order to talk to the PLC. As well as for locomotives, the green box utilized for rolling stock, it's designed specifically to meet the specification and certification for rolling stock. But if you wanted to utilize servers or your data center, the Sorbo SDC comes in a virtual environment that runs on a vSphere platform from VMware. A lot of the capabilities that we see now are expanding not only to sensors, but also to image processing, where now you can combine image processing with sensor data to build very smart algorithms and models. So that requires more GPU capability that traditional servers offer. The GPU can give you parallel processing, allow you to process and build models very, very quickly with image and sensors. The management platform is really a way to build a hierarchy of devices, sensors, tags, analytics, and manage them from an asset framework standpoint. As well as if, I know that for Wonderware, if you all are familiar with system platform, building a template and then be able to instantiate from that template to build children of that model. The same approach with the Sorbo management platform, where you're building a class for an asset, and in this class you build all of the entities that are that's required, the sensors, the real-time analytics, the machine learning models, all your devices, and then creating an instance of that model or template to deploy it out to the field. So if I had a locomotive or a robot with a certain type, I can then create 100 different classes of that robot instantly and making changes automatically. The other area of machine learning that a lot of analytics companies we have not seen today is managing and retraining. Part of machine learning is the ability to adapt to new information, new data. Requires you to retrain these models either on a periodic basis or on an event base. So part of the management platform lets you automate that process. So you can set it up to say every 6 months, let me take my new set of data, retrain the model, make it smarter, and now the ability to predict becomes a lot more accurate. And it also adaptable to degradation. With physical models and static models, we've seen, which we have experienced in the past, is having to constantly readjust those models to adapt to normal wear and tear. With machine learning, that becomes an automatic thing. As the retraining process now sees a new normal, it'll adjust itself for that particular mode. As we mentioned, most of what we do is in the predictive maintenance, but we're starting to see a lot more process optimization. And the paybacks are enormous. One of the examples I'll give you is we were at a client that was looking to predict problems with a web machine for building roof insulation. The return on investment for the customer was about a $30,000 to $40,000 downtime hit, which was significant. One downtime was a pretty easy payback. But having that consultative mode of selling as well as building that relationship with the customer, I was able to understand their business and advocating how we can then better improve their quality. I learned that their quality control was costing them millions of dollars. So using Sorbo to help improve quality had a much higher impact in addition to predicting a maintenance problem. So let's put this all together where we take real-time predictive analytics on the edge combined with cloud computing or on-prem. So you start off with your asset. In this case, we're looking at a chiller plant or any type of equipment that has ability to produce data. And if you don't have data, another option is to add sensors. One of the discovery phases is when we go into a project is, number one, do you have sensors where we can actually have data? If you don't get these basic elements, you can't do machine learning and analytics. So adding sensors is another option, as well as connecting to the PLC or built-in historians or SCADA systems. So collecting that data, we store it. The SDC, the Sorbo SDC, has the ability to store all the data on board, and what it does is then it does a call home protocol, which then says, I have to the Sorbo platform, I'm ready to send data, and using protocols like MQTT, HTTPS, it allows us to package that data in a JSON format, push it up to the cloud, where then the historian will archive that. From that data, you can then create visualization, dashboards, and do simple rule-type threshold-based alerts. While you collect and build history, then you can train models, more machine learning models that can predict maintenance events, quality events. And as you score these models and you create a high score, then you decide when you're ready to deploy them through the management platform. Those models get deployed back down to the edge. And now that edge processor not only is a gateway data collector, but it's now a machine learning processor making real-time predictions, making your machine smart, making your process smarter. Then those alerts are sent either via email, or it can be sent alert back to the PLC control system or to SCADA that will pop up a maintenance warning event on a HMI or SCADA screen. So these are all ways that you can incorporate analytics, machine learning into everyday production environments. Here's a real use case that we did for a manufacturer of construction-grade rebar. Their operation runs 24/7, 7 days a week, and they produce and convert scrap metal into steel. And each year they produce about a $1.1 billion or billion pounds of steel, of rebar that use in concrete. The problem that they were facing was the wire compactor was a critical asset in their production. The wire compactor basically compresses a spool of steel wire, and it ties the wire ready to be packaged and shipped out. So one of the challenges was that they were dependent on uptime, which is the last stage in this process, very much a bottleneck. Pressure cylinders within the compressor fail to control compression and speed, causing problems in the binding of the coils. Equipment failures occurred in the final stage of the production, causing the entire line to stop. So this became a critical asset that was unequipped with sensors. But the way we approached this is by using a Sorbo SDC, we connected to the Siemens PLC that was controlling the machines. We collected several months of data, analyzed the data to look for anomalies. So the first thing that you do is by processing this data with unsupervised learning gives you the ability to look at what are some of the abnormal conditions in this data. Then with every machine learning or deep learning project, you have to label the problems. Most of the issues that come with analyzing is how do we label it. So we look at a time event of an anomaly. We then ask a subject matter expert or yourself, if you understand the process well enough, was this a operating state, or was this really an anomaly or problem in the process that might have caused a downtime event? If that's the case, then we'll take that time event and train it on that series of data and then build a model to detect a particular problem. So in this case, we detected anomalies. So within about a 12-day lead time, we're able to predict and correlate some potential issues with the machine. So this particular customer realized about $100,000 in annual savings a year. So to wrap it up in terms of the Sorbo capability and the way the integrator provides value is offering this end-to-end solution, both assess, analyze data seamlessly to deliver operational improvements. The openness of the platform really allows you to interconnect with other systems. And again, edge is where we feel the industry is going. I believe a lot of the cloud platforms like Google, Azure, in terms of AWS, all of these cloud-based analytic companies have a purpose to process if you need the compute power, but in terms of delivering real-time solutions and the cost and practicality of transferring data is becoming more and more of an issue. So the edge is where we feel the industry is going. Own the data. A lot of customers that have come to us said that a lot of these companies that do provide predictive analytics basically only share the results. But the actual data itself, they actually monetize that data and use it for their own benefit. Customers are saying that we want to own our data, we want to be able to run our own models. So that is one of the key features about Sorbo is that it allows the customer to own their own data at a much more cost-effective approach, not having to need any data scientists or coders for that matter. The whole system is menu-driven, doesn't require any type of PhD in machine learning or data science. You can build your own models. It's designed for engineers and subject matter experts. It is an industrial platform, and it's unique capabilities as well to deliver value by combining sensors and image data that can create these confident models. And that is the end of my presentation. I am open for any questions. If you have any you'd like to post, please go ahead and post them. So
thank you. You can go ahead and turn it.
Yep,
you can type in the chat box any questions you might have in the lower left-hand corner.
We have our first question, Aldo, from John Watson, and his question is, what is the cost model of the entire Sorbo system, Sorbo platform? So I guess going back to your architectural drawing a couple slides back, it would be best to explain to John how we price the Sorbo solution from an integrator perspective.
It's really very simple. A lot of the cloud companies make it very complicated. I can tell you, you just go on to AWS platform where they give you a calculator right there that tells you it's a long process. With the Sorbo solution, it's really simple. There is a fee to buy the Sorbo SDC data collector, so one fee. There is also a subscription fee as well if you choose subscription model. So that's number one. Number two is you then pick a number of data points to collect. Basically, it's a service to store the data in the historian. That's based on how many data points. It ranges from about $20 to $100 based on how much data you want to store. That's number two. Then number three is where you build the machine learning models. The machine learning models are packaged in 10 and 20 models. So for example, if I build a model to detect a bearing problem or a belt issue on a conveyor line, that represents 2 models out of a package of 20. That 20 you pay an annual fee for, and if you want to add more, you basically add another package of 10 or 20. If you're looking at many different models across many different assets, there's there's scaling pricing to address volumes of agents and models. I hope that answers your question.
Aldo, we have another question from Ermil, and his question is, he's trying to understand how AI fits into this entire solution. So with AI being a big circle of different applications, machine learning is a subset of AI. And he's asking how exactly are we deploying AI to date?
Sure. So AI, artificial intelligence, it's kind of a very vague definition because AI can also mean building rules around in order to create some artificial intelligence. What we incorporate with Sorbo is more machine learning applying to AI and deep learning. The world of machine learning and deep learning does not require you to know pretty much anything about what you're trying to solve. It's feeding it a set of data set that you're allowing the model to learn that data set. So for example, let's take, I usually an image processing example because that's really more easier to understand. If I'm trying to train a model on your face or my face, I will feed the model a series of different pictures of both my face and other people's faces. So what the model tries to do is differentiate between my face and other faces so it can then identify that face. A sensor in a download or in a maintenance application, same type of approach. You're feeding it what looks like the problem to the algorithm, but you're also feeding what looks like normal data as well. So the algorithm can differentiate between the bad or the maintenance event from the normal data. That gives the model ability to say, okay, I see the signature starting to emerge in the data, and based on the way I have analyzed the data, it's going to fail within 2 weeks or 2 months. So machine learning is really the next level of artificial intelligence and deep learning. Now, deep learning is even beyond machine learning, because machine learning is using machine learning algorithms that are used to learn models. Deep learning is using more of the way the brain is designed. By using layers of neurons, these neurons and perceptrons are constructed to give you the ability to learn much more complex systems. So for example, if I took a paper machine, and if I understood the paper machine and all its different mechanical and operational events with its hundreds or even thousands of sensor inputs and outputs, for any human to understand the interaction between those inputs and outputs is literally impossible. The deep learning model allows you to build that layer as deep as you need to in order to give you a very good understanding of that machine. That, what we can build a digital twin that will then be able to give you all sorts of information. Predictions. When will my efficiency start dropping based on certain conditions? So for example, if I start to see in my deep learning model that it's predicting a lower yield or lower efficiency, I can then use the output of that machine learning model or deep learning model to then interact with my control system based on certain conditions. So really the next evolution of this is how it can automatically automate your process. So taking that expert knowledge, what an operator has learned over many, many years, building it into a digital model that is now able to interact with your machine and process. And the platform makes it very, very simple for you to make these models and build it into an application. So I'm sure people have done deep learning and machine learning, build it on Python and other scripting languages, which I've done myself, but understanding how to build that piping, understanding how to tune. One of the biggest challenges in machine learning and deep learning is tuning these models. They're very complicated in order to achieve a very high level of accuracy. The Sorbo platform does that all for you. It automates the entire process of inputting data, cleansing the data, pre-processing, dimensionality reduction to know what are the inputs that it needs in order to give you the best output, processing machine learning, and post-processing, as well as integrating it into your control system by linking that model to all of these sensors and giving you an output that gives you the prediction to your SCADA system. That was kind of a long-winded answer. Hopefully it answered your question.
No, that's a great answer, Aldo. Thank you for clarifying that. Hopefully it paints a good picture. Jeremy has a question here, Aldo, for you from a business perspective. As an integrator, Aldo, how would you advise clients, Jeremy's clients, on depicting a very good value-added, proposition picture with the platform and the technology, and how would you convey that to customers and be able to communicate it and tie it into their bottom line and talk about KPIs and the ROI from this kind of technology?
Yeah, great question. That's really the process on that consultative approach that we talked about, by discovery and advocating, where really, I can't stress this enough, you have to know the business almost as well as your customer does in order to help them through this process. A lot of times the customer, after building that relationship, will expose to you some of the critical assets in their process. As I talked about with that roofing insulation company, as I learned their business, understood their process, I was able to say, we can help you reduce downtime. But I was able to also ask them, what are some of the critical assets that give you the highest pain? And so by identifying those critical assets, and then how do we build the ROI, which is a good point, then having that relationship, you will then get some of the financials in order for you to build a good return on investment. And you do that in partnership with the customer, of course. So that really becomes part of that consultative relationship building that we talked about. And then at the end of the day, you want to be able to full circle and be able to say, did this machine learning or IoT predictive analytics solution did it deliver on its value by really measuring how well did we prevent a failure? If we did, how many catches did we see? So those are some of the things that really help the customer understand both the application approach, the return on investment, and the way to justify the cost of the project as well. We created I think we call it a discovery. Help me out, AJ. What's the document that we use?
It's called the success criteria document.
The success criteria document is a form that we use, and then we help that to basically complete that form. And that goes through the entire process of identifying the asset, to building the ROI, and then to understanding how we then justify and build the value, how it returns value to the customer. So that's the approach that we took from an integrator standpoint or a channel partner for Sorbo. Looks like that is it for questions. I guess we can wrap it up.
Yep, I can close this out. Parting thoughts, Aldo? If you have any parting thoughts, go right ahead, and then I'll close this all out.
No, like I said, if you have any more questions, we'll leave our information. You can definitely email me if you have any other pointed questions. I'd love to help you out and answer your questions for you.
Yeah, and to build off all this point, everyone will have a copy of the presentation. And in terms of following up, like I said, if you guys are wanting to really get a deeper dive on how we began this journey, please feel free to reach out. We're always available to answer any of your questions from an integrator perspective, because we strongly believe that this is the way in the future of the control systems community. And we believe that if we're winning and we're winning together, the entire community will benefit tremendously, because at the end of the day, it all comes down to the customer and being able to deliver value with new, emerging, and innovative technologies.
Thank you. On behalf of CSIA, I want to thank Aldo and AJ for this informative discussion, and I want to thank all of you for attending. We hope you found the webinar informational. When you close out of the webinar, a link will pop up to a brief evaluation. We'd really appreciate it if you could just take a moment to share your feedback with us. We also want to remind you that a recording of this webinar will be available for viewing within 30 days of this event. Visit the CSIA website to view the recording or a past webinar you might have missed. This concludes our program for today. Thank you again for joining us, and enjoy the rest of your day.